Hello, my name is Twisha Patel and this is the video for the Calculus Unit 5 summative presentation.
So this is Unit 5, which is derivatives of exponential and trigonometric functions. So here I've chosen topic 5.1, which is derivatives of exponential functions y is equal to e to x. So first we'll look at the property of the function y is equal to e to x. So since y is equal to e power x is an exponential function, it has the same properties as other exponential functions. So now let's look at the derivative of f of x is equal to e to x. So the derivative of this function is equal to e of x. It's the same. It's going to remain the same as the original value. Derivative of a composite function involving ex. So here, if x is equal function of x is equal to x to another function here, then the derivative of the function is going to be equal to e to the function, the original value, times the derivative of the other function here, which is this power 2x. So therefore the derivative of a composite function involving e of x is e to the function times the derivative of this function here. So here we're going to look at some of the examples. So here it says find the derivative of the following. So our function here is f of x is equal to e to 3x. So we have to find the derivative of e to 3x. So here what we're going to do is, as we saw here earlier, we have the original derivative, and then we multiply it with the derivative of the function here. But so we're going to use a similar method here. So first we have our original function, which is e to 3x, and then we multiply it with the derivative of 3x here. So here what we get is e to 3x into 3. So the derivative of 3x is 3. So the answer we get here is 3e3x. So therefore the derivative of f of x is 3e to 3x. So here we have another example. So this one is quite complicated. It's unlike the first one. So it says f of x is equal to e to x squared minus x. So this is a whole function on its own. So what we're going to do here is we'll use the similar method we used in the first example. So we have the derivative of this function. So I'll write down the function again. So that's x squared minus x. So this, as we said, we have the original function, which is going to be e x squared minus x times the derivative of the function here, that's going to be x squared minus x. So this remains the same, and the derivative of this function here is going to be 2x minus 1. So we simply multiply this and we get e x squared minus x times into bracket 2x minus 1. So this is the derivative of this function here. So next we have another example which looks quite different from the previous examples. So this one says f of x is equal to x squared ex. So this you see is more like a multiplication. So here we're going to use the product rule, unlike these previous examples where we used the chain rule. So here we're going to use the product rule, and we have the derivative of the function. So here what we're going to have is we'll first find the derivative of, we'll first take this value individually and we'll multiply it with this value, and then we'll add this original value times the derivative of this value. So here we'll first see we have we're going to take the derivative of x squared, so we have the derivative of x squared, and then we multiply the original value e to x here, and then we have addition, and we'll have the original value x squared here, so we have x squared, and then we have the derivative of e to x, so we'll multiply and we have the derivative of e to x. So this will give us 2x, which is the derivative of x squared, times e to x plus x squared, the original value, and the derivative of e to x, as we saw here, which said the derivative of a function e to x will remain e to x. So here we just multiply ex, and therefore here we have 2x e to x plus x squared e to x, and therefore we'll just factor out, since we see we have a common value which is e to x, and we have 2x plus x squared. So the derivative of this function here is e to x in bracket 2x plus x squared. And next we're going to look at determining the value of a derivative. So we can be given a function fx is equal to a third into e to 3x plus e to negative 3x, and calculate the derivative given that it's f of 1. So what we're going to do first here is we'll find the derivative of this function. So we find the derivative of this function, so that's going to be equal to a third into 3e 3x plus negative 3e to negative 3x. So since it's a third here, we'll divide the 3 cancels out for both these, and what we have here is e to 3x minus, since this was a negative sign, e to negative 3x. So therefore our derivative of this function is going to be e to 3x minus e to negative 3x. And now, since they said calculate, given that it has a value 1, what we're going to do here is we'll substitute all the x values here with 1. So we'll first write the original derivative value, which is e to 3x minus e to negative 3x. So once we substitute this value, we'll have e to 3x in 3 into 1 minus e to negative 3 into 1. So therefore we have e to 3 minus e to negative 3. So this is the value of the derivative. So that was it for my Unit 5 presentation. Thank you.